Ignition sequence starts.
Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Room. Flight Director Scott Stover and the Orbit 2 team of flight controllers are on duty now, keeping tabs on the space station systems and working with the Expedition 61 crew members as they finish up the last few tasks of another busy week in space. Commander Luca Parmitano and his crewmates have been supporting scientific experiments in the station's laboratories. They've also kicked off a new series of spacewalks to finish an upgrade to batteries out on the station's truss.
Welcome to Space to Ground. I'm Isidro Reyna. This week, spacewalks and science on station. NASA flight engineer Jessica Meir partnered for a second time with fellow NASA astronaut Christina Cook for a spacewalk on January 15th. This was the first of 2 battery replacement spacewalks this month. Meir and Cook replaced nickel-hydrogen batteries with newer, more powerful lithium-ion batteries for the power channel on one pair of the station's solar arrays. The spacewalking work continues the overall upgrade of the station's power system that began with similar battery replacement during spacewalks in January of 2017. A second spacewalk is scheduled for January 20th. NASA and SpaceX are preparing to launch the final major test before the astronauts fly aboard the Crew Dragon and Falcon 9 rocket as part of the Commercial Crew program. The test, known as in-flight abort, will demonstrate the spacecraft's escape capabilities, showing that the crew system can protect astronauts even in the unlikely event of an emergency during launch. The uncrewed flight test is targeted for Saturday, January the 18th, from Launch Complex 39A in Florida. After liftoff, Falcon 9's ascent will follow a trajectory that will mimic a Crew Dragon mission to the International Space Station, matching the physical environments the rocket and spacecraft will encounter during a normal ascent. SpaceX will configure Crew Dragon to intentionally trigger a launch escape prior to 1 minute and 30 seconds into flight to demonstrate Crew Dragon's capability to safely separate from the Falcon 9 rocket during ascent. This test is designed to provide valuable data toward NASA certifying SpaceX's crew transportation system for carrying astronauts to and from the International Space Station. NASA flight engineer Andrew Morgan and Commander Luca Parmitano of the European Space Agency were on science duty this week. The astronauts took turns safely burning fabric and acrylic samples to help scientists understand how flames spread in space. Understanding how flames spread in microgravity in confined spaces of different shapes enables the development of numerical models that allow designers and planners to anticipate fire behavior and create plans for preventing or extinguishing fires effectively in space. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
NASA TV and NASA.gov will have live coverage of that SpaceX launch escape test tomorrow morning, Saturday, January 18th, starting at 6:45 Central Time. Target launch time is 7 a.m. with a 4-hour launch window. And our coverage of the next spacewalk by Jessica Meir and Christina Cook begins on Monday, January 20th, starting at 4:30 a.m. Houston time. Wednesday's spacewalk was the 5th for Cook on her record-breaking mission. But it's not a spacewalking record I'm even talking about. The longest single spaceflight ever by a female astronaut or cosmonaut is now in its 309th day, with about 3 more weeks to go before her landing in Kazakhstan with Parmitano and Alexander Skvortsov. Cook's racked up quite a few memorable moments so far. Here are 2 of them.
Without a doubt, my most memorable day was day 1.
With the assistance of Space Station Commander Oleg Kononenko, Christina Cook of NASA, the first one through the hatch, being greeted.
That was the day that I have seared in my memory. Visions when I first arrived here, opening the hatch, seeing some of my best friends on the other side, floating through, seeing my first glimpses of the actual interior of the space station. After having traveled here for 6 hours on a small Soyuz spacecraft, that it actually exists for the betterment of humanity, doing science and exploring, that it was real and that I got to live here. I'm very privileged to have that as one of my favorite memories. One time as a crew, all 6 of us were together, and one thing we enjoy doing is singing karaoke, believe it or not. And we were belting out one of our favorite karaoke songs, Winds of Change. And as you know, we have the internet here supplied by a KU band antenna, which has passes where sometimes it has to reset and we'll lose that internet. So we're belting out Winds of Change, and all of a sudden the feed dies. And we go on and we're talking for a little while, maybe 10 minutes or so go by. And then suddenly the KU band antenna picks back up the satellite, and Winds of Change, our karaoke video, starts really loud in the speakers again. And without missing a beat, conversation instantly stops, and we all just resume singing immediately. And that was a really, really great moment.
As is the case for Cook, this trip to the International Space Station is the first space flight for her crewmate, Jessica Meir. But this is not Meir's first time in an extreme environment. She studied penguins in Antarctica and mapped caves in Italy, 2 activities that prepared her for the ultimate extreme environment.
The thing that's always driven and excited me is exploration in general. So I think I've always been attracted to these extreme environments, places where fewer people have been, where conditions are a little bit more harsh, a little bit more rare, and really extreme in general. I went to the Antarctic 5 times. 4 times was for my PhD research. And the work that we were pursuing then in the Antarctic was looking at the diving physiology of emperor penguins. They use this really big drill to create a hole in the ice, and so you enter the water through that hole in the ice. The first time you go diving through the sea ice hole, you really never forget the feeling. The water down there is a constant -2 Celsius, so 28 degrees Fahrenheit, and you can see rays of light coming in from any crack or hole anywhere around the area. And that's where you start realizing all of the color and the beauty in the Antarctic is. It's just an extraordinary experience. And the things that I saw underwater there is definitely the most remarkable and exceptional diving I've ever had. One of the things that we use for training for spaceflight for astronauts from all of our partner agencies is training in analogs. So if you try to think, what are useful training platforms on the Earth? How do we replicate all of the characteristics of a space mission? One of the analogs that the European Space Agency developed is called CAVES, and it's a technical caving mission. So the CAVES training mission was in this very extraordinary cave in Sardinia. So you would sometimes be crawling through a hole that when you see it in the distance, you don't think there's no way that you could even fit through that. You know, one at a time, we would take off our packs and sort of shimmy like a snake through these tiny, tiny little holes. And then all of a sudden you would come out into this room, this cathedral with a 100-meter granite wall. I mean, it was really just extraordinary. And then we would go on daily excursions, doing scientific experiments, exploring, mapping the cave. So all really similar things that we would do when we finally get to the point of exploring another planet, for example, as astronauts. And then also emphasizing all the other skills that we use on the International Space Station. The other connection that's really important to me is that all of these environments involve natural phenomenon on our planet. So it all goes back to my interest in biology, looking at this remarkable diversity in the animal kingdom with my previous research, exploring all of these amazing landscapes and ecosystems on our planet, and then eventually when I have the most extraordinary of any view, when I'll be on the space station in a couple months, looking down and seeing this magnificent planet Earth and seeing the beauty of our planet and really understanding how special it is and how fragile it is and how important it is to protect it, to take good care of our home planet, to protect our oceans, to protect the land, and to be really a good steward in our universe. I'm Jessica Meir. I'm a scientist and a NASA astronaut.
Mir and Christina Cook are getting ready for their third spacewalk together coming up on Monday, but they're already getting ready for that trip outside the airlock. Well, the truth is, preparations for a spacewalk actually begin even before an astronaut launches to space. In this demonstration video, astronaut Ricky Arnold shares some of the training that astronauts get on the ground to get ready to walk in space.
Welcome to the Quest airlock on the International Space Station. I'm Ricky Arnold, Expedition 56 flight engineer from NASA. Today we're going to talk about one of my favorite topics, extravehicular activity, or EVA. Going out on an EVA or a spacewalk has been one of the most amazing experiences of my life. But it's also one of the most complicated and dangerous things we do during human spaceflight. There's a lot of equipment to prepare and maintain, and we do months of training to make each EVA a success. If you think it sounds complicated, you should see all of it in action. Let's start with training and how we get ready for a spacewalk.
Space is an extreme environment that presents many hazards. If we're going to go outside the safety of the ISS, we have to be prepared. That's why EVAs are designed with safety as the utmost priority. We astronauts spend a lot of time in the classroom, just like you are now, learning about the hardware we'll be using and the specific parts of the space station we'll be working on. Then we get to go spend a lot of time training in NASA's giant pool, called the Neutral Buoyancy Lab, or NBL. Since it's impossible to simulate microgravity on Earth, the next best option is water, 6.2 million gallons of it. The NBL is 40 feet deep, 202 feet in length, and 102 feet in width. A lot of room to have a full-scale working model of the ISS, which we need for practicing our EVA maneuvers and assigned tasks. We get suited up and weighted so that we're neutrally buoyant in the water, so we don't sink to the bottom and we don't float to the surface. It's a great way to simulate the microgravity we'll be experiencing. We do several dress rehearsals of the EVA before we launch. This gives us the opportunity to prepare for any anomalies that may occur. We spend at least 5 hours practicing in the NBL for every 1 hour planned for the spacewalk, so we are very well prepared to execute the EVAs once we are in orbit. Once we are up in orbit, the EVA preparation continues. First, we must perform a pre-breathe protocol to displace the nitrogen in our tissues and help prevent a condition called decompression sickness. During pre-breathe, we breathe 100% pure oxygen and do some light exercise to help purge the nitrogen from our bodies. During pre-breathe, we will also don our extravehicular mobility unit, or EMU. This is a fancy name for a spacesuit. The spacesuit is basically its own spacecraft, shaped like a human. There is usually a red stripe on the leg of one astronaut, but not the other, so the ground can tell who is who. To ensure our safety at all times, we are always aware of our safety tethers and where we are in relation to our spacewalking buddy.
Hey, buddy.
There's a fellow crew member called the IB, the intervehicular crew, on the inside of the airlock, watching and communicating with us as the EVA progresses. We are also prepared for several contingencies should they occur. First, we are trained on the use of a jetpack that can be used to maneuver in the event of an emergency rescue. It's called a SAFER, or Simplified Aid for EVA Rescue. The view during an EVA is magnificent. It's beautiful out there. It's also extremely dangerous, but our months of preparation and all of those dedicated people working on the ground, working around the clock, ensure we are safe as possible when we work outside the ISS. EVAs have allowed us to build and maintain the ISS, repair mission-critical hardware, investigate malfunctions, install new hardware, and the view, unbelievable. See you next time.
If you've watched NASA TV coverage of the spacewalks, and you are encouraged to do so, you've had the chance to see some terrific views of planet Earth captured from 250 miles above as the International Space Station cruises along at about 5 miles a second, along with cameras that are permanently mounted on the outside of the vehicle and other cameras in the hands of the spacewalkers. The station has some great picture windows that the crew members can use. And in the Destiny laboratory, they have a special piece of hardware that combines art and science.
An intersection of art and science on the station. Presented by Science at NASA. Large and powerful telescopes have delivered stunning images of our galaxy and the universe. A little closer to home, my colleagues have taken some equally stunning photographs of our own planet from the International Space Station. My name is Mario Runco, and I'm an Earth scientist and former Space Shuttle astronaut. After seeing our beautiful home planet from orbit, I wanted to be able to share the experience with everyone. So one of the NASA accomplishments of which I am most proud was helping to spearhead the creation of the WRF, the Window Observational Research Facility on the ISS. My colleagues, Dr. Dean Epler and Dr. Karen Scott and I, envisioned a small facility, about the size of a large refrigerator, that would enhance the capabilities of the large Earth-viewing optical quality window that we were previously successful in getting aboard the station. This vision became reality as the WRF was launched to the station in 2010 on board the STS-131 mission of the Space Shuttle Discovery. The optical quality window and the WRF are a perfect blend of art and science. They allow us to conduct Earth science research and capture amazing high-resolution photographs of the Earth. The window is located in the U.S. Destiny laboratory module and features the highest quality optics ever flown on a crewed spacecraft. It is 20 inches or 51 centimeters in diameter and includes a non-optical quality retractable pane that protects it when it is not in use, but still allows natural light into the station and provides a great view for the crew. The WRF is capable of housing a variety of sensors within the shirt sleeve environment inside the space station and serve as a testbed for the development of new sensor technology. These sensors can be used to study atmospheric, oceanic, and surface terrain conditions, as well as make environmental health assessments. Observations made from the WRF can provide important data on transient atmospheric and geologic phenomena, such as tropical cyclones and volcanic eruptions. It also helps us to better understand our local solar system environment. The National Laboratory Meteor Investigation allows for spectroscopic analysis of meteors as they enter the Earth's upper atmosphere. The WRF's presence on the space station allows its sensors to image the same location or region multiple times over several days. This allows for observations that can show, for example, how vegetation below may be changing from day to day. Subtle changes detectable by orbital sensors that might be indicative of declining plant health are rarely visible on the ground in their early stages, and often by the time they are, it is too late and crops or even forests may be lost. My colleagues and I are all avid Star Trek fans, and we decided to name the facility WRF after the Honorable Klingon warrior. We designed a mission patch that included Klingon script for the acronym WRF, and even an alternate version with a depiction of an astronaut bearing an uncanny resemblance to Science Officer Spock, making observations of the Earth from the WRF. For more of the many wonders that can be observed from Earth orbit, go to nasa.gov/ISS-science. For similar out-of-this-world stories, visit science.nasa.gov.
2019 was a busy year of science aboard the International Space Station. In November, we kicked off the 20th year of continuous human presence aboard the space station, which so far has hosted 239 different human beings and more than 2,700 science experiments. During the past year, research has ranged from growing leafy greens in microgravity to analyzing mining microbes to testing out autonomous robots. All research that's benefiting people on Earth while helping prepare us to go forward to the Moon in 2024 and then on to Mars. NASA astronaut Anne McClain, who you saw a couple of times in that piece, launched to the International Space Station on her first spaceflight 13 and a half months ago for a journey that ended up lasting more than 200 days. Since her return to Earth, McClain has talked about how her perception of her home planet was changed by the experience of her first spacewalk.
On the day of the spacewalks, I remember I was over the hatch and they said to open the hatch, and so I opened it up and it was daytime. And the only thing I could look at was straight down at the Earth. And for 10 minutes, I just watched the Earth going by below me, and the only thing separating it was just my visor. And it was really incredible. And then we exited. They said go ahead and exit the space station. And I remember that was the first time I really got the sensation that I was being pulled by gravity. I was close to Earth, and I was very reliant on physics at that moment because I was holding on to the space station with one hand, and my feet were dangling. I remember, not just through my visor, but looking down, and you just see feet and then Earth, and you're holding on to the space station, and I mean, it was just incredible. Everything looked so large. But again, the most significant realization to me was looking out and realizing not how far I was from Earth, but how close I was to Earth and how connected I was to Earth, and how, we on the space station plus everybody on Earth and this planet is actually so small compared to this vastness of outer space. We have a small amount of gravity that keeps us in orbit around the Earth. And I was keenly aware that Earth was holding on to us. We were attached to Earth. What was amazing to me was looking the other direction and looking out into deep space, and it was infinite. And I realized, as I had one hand on the side of space station and we were both orbiting Earth, I felt I was very connected to Earth, like it was mine. There was some ownership there, and not my hometown or my city or what I was familiar with, but the entire Earth. I felt an ownership and a kindred spirit with every part of it. You do feel this closeness to every human on Earth. You have this really distinct recognition that every single person you will ever meet, you have more in common with than you do different, no matter what. Having been part of a program that takes so many people working together and doing the right thing, and you go, wow, look what we can do when we focus on that majority of us that are alike, that have a common dream. No matter where we grow up, everybody looks up at the sky and says, what else is out there?
Anne McClain spent more than 200 days on the space station. The longest spaceflight ever by a female astronaut is now about 20 minutes longer than when I mentioned it 20 minutes ago. Christina Cook's mission elapsed time is now 308 days, 15 hours, 23 minutes, and counting. That started with her launch from the Baikonur Cosmodrome last March and is due to end when she joins Russian cosmonaut Alexander Skvortsov and European Space Agency astronaut Luca Parmitano for a short Soyuz ride back to Earth in early February. Here's what she had to say recently when we asked her to recall some favorite moments from her flights, her favorite meal, and favorite view from orbit.
I'd have to say any meal that we share together is a great one. And of those, some of my favorites I would say would be our pizza nights. Our folks on the ground send up care packages sometimes, and they'll put together a little non-perishable pizza kit. And we're able to actually make pizzas in our kind of makeshift space oven using tinfoil and a little bit of creativity, and seeing what everybody comes up with and sharing with each other, and just something a little different, a little bit out of the norm that we actually feel like we get to prepare ourselves as opposed to just opening up out of a packet. It's really special and it's a lot of fun. One really striking moment was the first time I saw my hometown in the area where I grew up, which is coastal North Carolina, and seeing those Outer Banks come into focus around the horizon and suddenly realizing what I was looking at was a just breathtaking moment. Some of the other favorite things I have to look at would be definitely the auroras, the northern lights and the southern lights. And those are really special to me because I spent so many years working in the Antarctic and the Arctic and seeing those auroras from below. And so to see them on a planetary scale from above is just truly mind-blowing.
If you'd like to get another look at any of these stories we featured today, and who wouldn't, check us out on YouTube and Facebook at those addresses right there. And when you go there, look around, because there's lots of cool stuff you will find about NASA and America's human spaceflight program. And if you're out on the internet anyway, check out Houston We Have a Podcast. That's where we talk to folks about their work in all aspects of space exploration. New episodes post every Friday, and today we continue a special series on NASA's Human Research Program with a discussion of the effort to bring together and implement the research that's being done by several specialty areas in that office, all working to identify the threats to human health that are faced by astronauts in the spaceflight environment, be it low Earth orbit or on the moon or on the way to Mars or at Mars, figuring out how to mitigate and eliminate those threats. Go to nasa.gov/podcasts for today's episode. It's where you'll also find all of our previous episodes and the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.